Question 16. The incomplete table shows information about the times and minutes that runners took to complete a race. So 12 runners took between 30 and 35 minutes, 20 runners took between 35 and 40 minutes, unknown amount took between 40 and 50, so on and so forth. Use the histogram to calculate the number of runners who took between 40 and 50 minutes to complete the race. So this value here is what we're looking to figure out for the answer to part A. Now our table has four complete pairs of values of four. Normally this is written in rows, but they're written as columns for this question. So four complete columns, as you see here, with one missing. Our histogram below has two bars, 1, 2, and 3 missing other bars, whatever they are going to be, right? What will happen with this is if you've got an incomplete table and an incomplete histogram, there will always be one of the bars that matches one of the columns, in this case, of the table. So having a look at the fact that this one is 40 to 50, well, 40 to 50 is the one that's missing, so we don't have that. But we do have 50 to 60. So I'm just going to highlight this box here in red because this is our link. That there is linked to this here. Now we have a frequency, the number of runners is known as the frequency because there are 12 runners that are, in this case, 50 to 60. This 50 to 60 visually here in the bar has a width, class width of 10 in this case because it's between 50 and 60. And this other measurement that we have here is frequency density. Now we don't know what the frequency density is, this marking, this height there of that bar, but we don't need to because area in a histogram is what frequency is all about. So this frequency here, should really highlight, no, I'll keep that in red. This frequency of 12 is the area of this bar. So the area of this bar is 12. The width is 10, which means if we do 12 divided by 10, we get 1.2. 1.2 is going to be that height there, that marking. And that then allows us to fill out the rest of this scale and as such be able to figure out stuff to do with this bar, be able to figure out other bars, so on and so forth. It's kind of like the dominoes all fall from there. So based on the fact that that's 1.2, that means that these two are going to be thirds of it, so 0.4 and 0.8, and then I can fill in all the blanks after that. After this, we're going to establish what the height is of the bar that's been given there, which is exactly halfway between 3.2 and 2.8, so the height of that bar there is going to be 3. The width of that bar there is 10, which means the area of this bar is 3 times 10, which is 30, and that 30, that area, is our frequency, is the number of runners in that bar. Therefore, we have completed the table. For part B, completing the histogram with the remaining results, well, we have all of the frequencies, which means we have all of the areas of each of the remaining bars. And if we have the areas and we have the widths, then we can figure out what the heights are. So each of these are areas. We have our widths, which is the difference between the numbers either end of the class. So the width of that is going to be 5. The width of this one is also going to be 5. And the width of the last one is going to be 20. And then we take each of those widths. No, what am I talking about? We take each of these areas, 12, 20, and 16, and divide by the widths, 5, 5, and 20. And the answers we get here, 2.4, 4, and 0.8, they are going to be the frequency densities, the heights of our bars. So the first bar, 30 to 35, has a height of 2.4. 30 to 35 has a height of 2.4. Therefore, that bar is going to be like so. Do a different color for the next one. Let's go with this one. 35 to 40 has a height of 4. So that one I'd actually have to keep going. The markings will be up to there. This gives us this bar here. Shade it in. I mean, don't think you have to shade them in, but it looks better that way. And then the last bar, let's go with grey. We have a 60 to 80 width, and our height is 0.8. So all of the rest of grey is maybe a bit boring, but anyway, too late now. That there is the last bar. Next part of the question. Runners who achieved a time between 37 and 48 minutes to complete the race were each awarded a silver medal. Calculate an estimate for the number of runners awarded silver medals. Well, it's an estimate because of the fact that we don't know what times those 12 runners got, other than it was between 30 and 35. We don't know their exact times. But we use an estimate by kind of assuming that the parts of the bars that we look at, so for example, this bar here has 30 people in it. If we take half the bar down the middle, we assume there's 15 here and there's 15 there. We use direct proportion in that sense for it. For the question, for the times that we're interested in, it's 37 and 48, so that 37 is here and that 48 is there, which means the parts of these bars that we're interested in, we're interested in 3/5. This in here is going to be 3/5 of that bar that we're interested in, and 48, that in there is going to be 8/10, or in other words 4/5 of that bar. So 3/5 of the people in the lime green bar and 4/5 of the people in the blue bar here we care about. They're the ones that are going to get silver medals. So 3/5 of the number of people that were in the lime green bar, that was 20, 3/5 of 20, and 4/5 plus 4/5 of the number of people in that blue bar was 30, so 4/5 of 30. These are all the people that are going to get silver medal. So we're going to do 3/5 of 20, which is 12, 4/5 or 8/10 of 30, which is 24. Add them together. 36 people is the estimate for the number of people that got a silver medal.